Howdy Year 9, my name is Mr. Crouch and I'm one of the prac students here at Kringle High in Science this term and for the start of next term as well. So I'm working with Mr. Ryan and Mr. Bizet for the rest of this term with Year 9 to help deliver the content on plate boundaries or plate tectonics. And so I'll be taking the lessons for this week and putting forward a few videos for you guys to watch and a couple of worksheets, and be there if you need any help to work on some of the content. So last week with Mr. Bizet, you touched on the layers of the Earth, you also touched on what plate tectonics were, and you also touched on what volcanoes were. So this week we're going to start to address a little bit more of what's in the assignment, and we're going to start off by looking into the risks associated with some of the plate boundaries. Now this is important for your assignment. We'll touch on volcanoes in tomorrow's lesson, but for today we're going to focus on the plate boundaries. So before we get started with this lesson, there is a worksheet for you guys to work on. You can access that in the Year 9 KHS Google Classroom, which is attached to this material. Feel free to complete that as we go along with this video. Alternatively, you can complete it after you watch the video, or if you so choose to do so, you don't have to actually watch the video, but watching the video will be a great help to you, and it pretty much goes through most of the answers for you. So before we get started, let's have a crack at some revisions. So referring back to Tuesday's lesson last week with Mr. Bizet, so there are three main types of plate boundaries that we have. So we've got convergent plate boundaries. Now these are the plate boundaries that are coming together and crashing into each other. We've then got divergent plate boundaries. These are the plate boundaries that are going in the opposite direction of each other, so they're going away. And then we've got transform boundaries. Now these are the plate boundaries that are rubbing up against one another and causing a lot of friction. All right, so we've got convergent plate boundaries which are coming together, divergent that's going away, and transform that is sliding up against one another. Now, referring back to Tuesday last week as well, there's two main types of crust on Earth. So we've got our continental crust, that's where all of our continents and our countries and stuff are. That tends to be a lot thicker, but it's a lot less dense. It forms like most of our land masses. It's comprised mainly of granite, and it generally tends to be older than the oceanic crust. Then we've got our oceanic crust, which is thinner and more dense. It tends to be located under the oceans and the seas, and it's composed mostly of basalt, which is another type of rock, and it's generally younger than the continental crust, and we'll cover that a little bit later. And as you can see in the image on the right-hand side, you can see the oceanic crust on the left, which is quite a thin dark brown layer, as opposed to the continental crust, which is a lot thicker. So during this lesson, you're going to learn about the different types of risks associated with plate boundaries and learn some strategies to live with these risks. And to be successful in this lesson, you need to be able to identify the risks that come about from plate boundary interactions and to describe strategies humans can use to minimize, avoid, or live with the risks and stay safe. So to make this easier for you guys, we're going to break it down into 3 parts. Or 4 parts actually, but we're going to break it down into each of the different types of plate boundaries. So we'll start off with convergent plate boundaries, remembering that these are the plate boundaries that come together and run into each other. All right, so Mr. Bizet brought this up last week. So there's 3 types of plate boundaries. So we've got continent-continent, which is when 2 continental plates crash into each other. We've got continent-ocean, which is when a continental and an ocean plate crash into each other, and there's some subduction happening there. And then we've got an ocean-ocean plate, ocean-to-ocean convergent plate boundary as well. All right, so we'll start off with continent-continent plate boundaries. So this happens when the 2 continental plates collide. And the main risk or the main feature that we end up seeing from this is actually what's called folds. Now, if we think of this like clothes that we've thrown onto the ground, all right, just throw them anywhere, what happens when you push at it from each side and you push it together and you kind of compress it? What's happening there is that it's creating what's called folds. Now, rather than the rocks just breaking and going off and doing their own thing, the continental crust is actually kind of folding in on itself and pushing upwards. Now, this ends up forming what we call mountains, or fold mountains in this case here. And a perfect example of this, or the best known example of this, is actually the Himalayas, which is in the Asian continent. All right, continent of Asia. That's where Mount Everest is. So that's a really good example of folds and the risks that sort of come from that. Another sort of risk that comes about from the continent-continent convergent plate boundaries is faults. Now, not in every single case will the crust just kind of crumple upwards and go up towards the sky. Every now and then you're going to kind of get sections that sort of catform one another, and instead of crumpling up or folding, it's just going to slide and sort of separate on itself. So this is what we call faults. Now, faults are quite well known as linking into earthquakes, and we'll touch on that in a little second. But actually, yeah, we're touching on earthquakes now. So, as a result of these faults, sometimes when they catch and they build up a lot of energy, when they snap or when they release that energy, we get what's called an earthquake. Now, with continent-continent convergent plate boundaries, these don't tend to cause very big earthquakes. And we won't get too much into why that is, but what does happen though is that when that energy is released, it has to go somewhere, and it tends to go up through that thicker crust, and causes that earthquake. Now, there are a lot of other risks that come from that, such as things like landslides or avalanches, but we're not going to touch on those with this PowerPoint slide today. Now, the next part of the convergent plate boundaries we're going to touch on is the continent-ocean plate boundaries, and this happens when a continental and an ocean plate boundary collide. Now, one of the main risks that happens with this is we're going to see earthquakes. Now, unlike the continent-continent convergent plate boundaries, where there's a lot of land mass and like a lot of rock layer in that thicker continental crust, when you've got a continental and an ocean plate boundary colliding, there tends to be a thinner layer or a thinner area for that earthquake to occur, and there's less rock essentially, or less thickness for that energy to be absorbed. So not the perfect picture for this, but if you look it up in your own time, you'll be able to see that when there's the subduction happening, so you've got your continental crust and your ocean crust, the ocean crust, which is more dense, is going to go under. It's quite thin as well. When those rocks rub against each other and there's a fault that occurs, all that energy is going to go up through that thinner layer, and you're going to get larger earthquakes in these continent-ocean plate boundaries. Now, from this as well, when we get that earthquake happening, generally linked in with that, we get tsunamis. Now, as you can see in the image on the screen, with that fault line, when one layer of the crust comes up and the other goes down, we tend to see an upward wave. Now, this isn't the only example of what we might see. Sometimes the fault line might actually go in the opposite direction, and water might be sucked down and then pushed back onto the earth. Onto the land. Alternatively, in this case here, where we've got the fault line that's going up, the upward wave is pushed up, and that tsunami is going to go across and it's going to hit land. Now, we also tend to see quite a bit of volcanic activity at a continent-ocean convergent plate boundary. Now, if we observe where the subduction zone is, now this isn't, actually this is a good example. So we've got the ocean crust on the left-hand side of the image where that subduction zone is. Now, where that subduction zone is, that tends to be quite often where the earthquakes are going to happen. But there's going to be an area of weakness in that continental crust layer, and that's going to cause a lot of the magma that's in the earth to push up and find that little weak spot and come out in the form of a volcano. And finally, we've got ocean-ocean convergent plate boundaries. This is when two ocean plates are colliding with one another, very similar to when two continental plates collide with each other. So with this one here, we tend to see a lot more deep earthquakes. Now, your ocean-ocean continental plates tend to be quite low into the ground. Obviously, you've got a huge ocean over them, so you're going to get a lot more deeper earthquakes that tend to be more like the mantle layer, as opposed to on the crust directly. You're going to see a lot of ocean trenches. Now, as you can see with the subduction zone, when these two plates are colliding, sometimes rather than going up and creating mountains, they're actually going to go down with one another, and that's going to create a really big trench. So there's like a really cool area called the Mid-Atlantic Ridge. I'm pretty sure Mr. Bazet touched on last week. And even the Mariana Trench in the Pacific Ocean plate area. The subduction zone has caused a really big trench to occur there. And finally, you can also get some volcanic islands. So similar to with the ocean continental plates or the continental ocean plate boundaries that are converging in on one another, you get similar sort of activity when you've got an ocean continental plate crashing into one another. The reason this happens is that one oceanic plate tends to be a little bit older than the other one, and so that older one is going to have a little bit more strength in it, so that's going to cause it to essentially act as if it's a continental plate and remain on top, and the younger plate, which is more dense and a little bit thinner, is actually going to go under as well, and so you're going to end up with those volcanic islands forming as well. Now, contrary to popular belief, we would think that Hawaii, which has got a lot of volcanoes on it, would be an example of these volcanic sort of islands that are forming as a result of plate boundaries. This isn't actually the case. Hawaii is actually located smack bang in the middle of the Pacific plate. So feel free to look up that in your own time and try and do a little bit of an investigation as to why you think there's a lot of volcanic activity there, even though it's not near a plate boundary. So the next plate boundaries we're going to look at are the divergent plate boundaries. Now these are the plate boundaries that are going away from each other and then creating that kind of gap in between them. All right, so there are two types of plate boundaries with divergent plate boundaries. So we've got continent, and we've got ocean. Now you might be thinking, Mr. Crouch, why isn't there continent ocean plate boundaries? There are, but they don't tend to be as common. It's essentially the same as if you've got continent or ocean. So those risks are sort of enveloped into both of those. All came through at the same time. So when you've got continent risks, now these ones are going separate, away from each other. One of the most common risks that you'll notice is the creation of a rift valley. This is essentially the two land masses that are moving away from each other, then it's creating a big valley in the middle. That can pose quite a lot of risks, especially with things like development or roads, because over time, even though those plates are only moving at about 3 centimeters a year, over time that'll build up and it can eventually like create such a big gap that if you had, like, say, for example, a bridge going over it and you didn't think to fix it, that bridge could collapse. You can also observe some quite shallow earthquakes as well. Now, even though these continental plates are moving away from each other, there's still sections in there that can create some faults in there. So those rocks can slide against one another and they can create those earthquakes. They're not going to be as big as those with the subduction, so with the continental and the ocean plates, which go under under each other, but they can still occur. And then we can also get some minor volcanic activity. Now, as these plates are separating, you're essentially creating a region which is closer to the Earth's mantle. And if there's an area of weakness in there that forms, you can get some volcanic activity happening. So that magma under the Earth's crust is going to come up and you'll create some volcanic activity in there. With the ocean divergent continental plates, a similar sort of things happen, except all of this is happening underwater. So we'll touch on the first one last, but let's look at the middle one first. So we get those shallow earthquakes, so very similar to what's happening with the continental divergent plate boundaries, the ones that are separating. Sometimes those faults are going to occur and you're going to get some earthquakes happening. You're also going to notice a bit of a volcanic activity. Now, those oceanic plates are a lot thinner than those of the continental ones, and so they're going to be a lot closer to the magma that's under the crust. And what's happening is when you're separating those plate boundaries, you're exposing all of this water to the hot magma that's underneath that crust, and that's going to result in a lot of volcanic activity that's going to happen in those regions. Now, what also happens, if we refer back to the first one, we've got what's called underwater mountain ranges. Now, you wouldn't think that this would happen if you're separating two continental plates, but what's actually happening is when you're separating those plates and that hot magma is coming up and interacting with the water, that hot magma is going to spew up and it's going to solidify in the cold water. And what that's going to do is it's going to go over the edges of those plate boundaries and it's going to stack itself up over time. Think of it like a bit of an eruption, like a big volcano. And over time, what that's going to do is that's going to harden and it's going to solidify and cool down, and it's going to create those really cool mountain ranges. So as you can see, there's a solid line in the middle of the Atlantic Ocean. So it's like a bit of a green inside all of the blue. That's an example of an underwater mountain range, and you guys will research that in your worksheet. And finally, we're going to touch on the transform plate boundaries. So remembering the transform plate boundaries are the ones that go side to side like that. All right, and there's a lot of friction between them. Now, you can see on this GIF here, it's pretty much just what I explained before. So they're pushing against each other and they're creating a lot of that friction. Now, there's two main risks that happen with this one here. The first main risk is going to be shallow earthquakes. Now, these are the earthquakes that are going to be some of the worst ones that we see. So with these plate boundaries, there's going to be a lot more faults. There's going to be a lot more interaction and a lot of more energy being stored up between the movement of these two plate boundaries. And as that's released, that's going to create what's called an earthquake, and it can be quite detrimental to the Earth and like the crustal layer. What we also notice with this one is land displacement. This is obviously one that's going to happen a lot slower. So the plate boundaries or the plates themselves are only moving at about 3 centimeters a year. So over time, you'll see a lot of land being displaced. So if we look at that road just there, if we had a road there for 100 years, each year it's moving about 3 centimeters. That means it's going to move about 300 centimeters. So it's going to move about 3 meters different over that 100 years. So that road would definitely be a little bit out of place by that point. So what we're going to touch on now is a couple of minimization strategies for the plate boundaries and the interactions between them. Now, we're only going to talk about 2 of them here because I want you guys to research a third one of your own choosing, and I don't want to give too much away so you're not getting too bored. So the first risk that we're going to look at is earthquakes, and this is one that was identified pretty much with all of the plate boundary interactions. And so there's plenty of different ways that we can look at minimizing the risk of these earthquakes. Now, earthquakes, we can't get rid of them. They're a fact of life. They're going to happen while there is some tectonic activity, some plate tectonic activity. But one of the technologies or one of the strategies that we can use is like the use of technology to observe the faults. So we can look at the plate boundaries. We can go, okay, this is an example here of an active fault that might, accidentally or not accidentally, it might snap and it might release that energy and cause an earthquake. So we can kind of keep an eye on it and go, okay, this is an area here that might experience an earthquake, so we should be wary of this. Looking at the second point there, so developing earthquake-resistant infrastructure. Now, we obviously can't get rid of earthquakes. What we can do is we can minimize the amount of damage that those earthquakes can inflict on us. So in a lot of countries that are around the Pacific Rim, so around the Pacific Plate, so like in the Pacific Ocean, especially places like Japan or Taiwan, they've developed a lot of infrastructure that is designed so that as an earthquake happens, it'll actually vibrate or oscillate in the opposite direction. It'll counter out the movement of the earthquake so that that building will stay up nice and tall. And the third strategy that we can implement is building away from plate boundaries. So places like Australia, we're smack bang in the middle of the Australian tectonic plate. And with that, we're quite far away from a lot of the plate boundaries. So we're not going to experience as many earthquakes as countries say such as New Zealand or Japan. We'll still feel them every now and then. They can happen. But because we're further away from those plate boundaries, we're minimizing our exposure to these earthquakes. And the second risk we're going to look at is a tsunami. Now, tsunamis go hand in hand with earthquakes. So generally, if there's an earthquake, if it's of a large enough magnitude, a tsunami can closely follow. So we can use seismic monitors to detect earthquakes, and we can use that to then feedback data to say, for example, if we record that there's an earthquake happening and we know that it's a magnitude 8 earthquake, we can go, okay, there's a very, very high chance that a tsunami is going to happen. Let's warn people in this country here or in this location that they're going to need to get to higher ground or they're going to need to evacuate. Which goes on to the second point, which is the implementation of tsunami warning systems. So this would link into things like sirens or text messages and things like that effectively warn residents or people that a tsunami might be coming and that they should seek higher ground or they should seek shelter and do stuff like that. And a third strategy or technology that we can implement is the effective planning of evacuation. Now, obviously, in the event of an evacuation, everyone's going to want to panic and they're going to want to try and get out of there. That's why it's important to have strategies in place so that you can do a really smooth evacuation that's going to be nice and quick so that as many people as possible can be saved. So now that you've watched this video, what you guys need to do is you need to go and complete the worksheet if you haven't been working on it already. You will need to do a little bit of research in this worksheet on your own, so feel free to pause the video or go back and look at some of the information in the video as we go along. Once you finish that worksheet, make sure you submit it into your own individual Google Classroom so that your teacher can have a look at it and make sure that you're attending class and engaging in the content. And then after you've done that, you've got some spare time, keep working on your assessment task. We are going to touch on some more assessment task content later in the next couple of lessons, but it's always good to make sure that you're on top of it now. So thanks for listening, Year 9, and I'll see you guys tomorrow.